silicon diode, 5 volt, and this is the, okay, like this, 1 kilo ohm, this is the 5 volt, and this is the, okay, in this one how much loss will be there? 0.7 volt. Okay, so how much will be left here across this? 4.3 volt will be left. So we can say here in this one, your I will be equal to how much? 4.3 divided by how much? 1 kilo ohm. Answer we can write it with the 4.3 milliampere. Okay, suppose this is germanium, then what will happen? In germanium, you have to take how much loss? We need to take, in case of germanium, we have to take how much loss? 0.3 loss we have to take. Okay, 0.3 volt drop will be there. So we can say here 1 kilo ohm. So here out of 5 volt, it will be left how much? 4.7. So now we can, current will be how much? 4.7 by 1 kilo ohm. Answer will be here 4.7 milliampere. Suppose both are given together. If both are given together means we are having your silicon also. We are having our germanium also here. Silicon and germanium both are together. If both are together, then what happens? We can say here how much loss? 0.7 volt. Here how much loss? 0.3 volt. So how much will be left here in this one? We can say 1 will be gone. So 4 will be left. So we can say I will be equal to how much? 4 by 1 kilo ohm. So it becomes 4 milliampere. Okay. In this one, I have taken just one. Okay. Now can I take one more? One next question. Okay. Have you written this one? Good. Next question. Suppose I have taken like this. What do you say about this one? Now, is there any current or no current? You know, when you will check this one, you will find this is the forward bias because this is the positive, okay, positive here. But here you will check this is the negative, so this is the reverse bias. And if reverse bias, then you have to cut this circuit. When you will cut this circuit, then current will be how much? 0 current will be there. Okay, reverse bias you have to remove. There is 0 current. Okay, if I give you this thing now. Now, 50 ohm, 50 ohm, 50 ohm, all are 50, 50, 50 here. And this is the 5 volt here. So in this one, you need to answer this. What is the current? Okay. You know that here in this is forward biased because positive, no? So positive here, positive here, positive here. This becomes your reverse bias. Reverse bias means you have to ultimately remove this. This is also forward. Okay. So one will be removed. And when one is removed, then you can say this is the 50 left here. This is the 50 left here. And then we can say this is the like this. Okay. Situation. 50, 50. And this is your how much? 100. You can say 50 and 50 are in parallel. 50, 50 in parallel means how much? 25, and this 100 is in series, so we can say R equivalent will be here 25 plus 100, that comes 125, and we can write current will be equal to 5 by 125. Yes, 5 by 125, na? Clear? Yes. Okay. Can I take next question now? Next one. Next one. Now questions are identical. You need to just identify which one is the forward, which one is the reverse. Okay, when nothing is given, then it is taken as ideal. Okay, if I don't tell about your diode, then diode is considered as always ideal. Okay, otherwise I will specify silicon or germanium. Okay, now You know, in this one we can say this is R, this is also R, this is also R, this is also R. So first of all we can say this is the high here, this is the low. Here high, here low, here high, high, high. So here high and here low means positive, negative, or I can say high, low, no problem. Okay, this resistance is between high low, this is between high low, this is between high low, all are between high low. Only thing, the diode you need to check, this diode is forward or reverse. What do you say? This diode is forward or reverse? You can say in this one, this N terminal is connected with high. If this is connected with high, then this becomes reverse. And if this is the reverse, then you have to just cancel whole circuit of this. So how many resistance will be left? How many will be left? Only 3 will be left. Okay, and then only 3 will be left, and all are between high and low. We can say this side high, this side low. All are between your high and low. Okay, all are between high and low here. So we can say this is the R, this is the R, this is the R. So we can write your R equivalent is how much? R by 3. Okay, clear? R by 3. Then if they're asking current also, then we can find our current. Current will be just V by R. Okay, can I take next question? Next. Okay, next one. In next question I am going to take here, this is silicon, this is germanium. 5 volt, this is the 1 kilo ohm. You know which path they will follow? Which path they will follow? Electron follows least resistive path, or we can say current follows least resistive path. Okay, means current follows which path? Least resistive path. Okay, if follows least resistive path, you know here how much it have to lose? 0.7, and here it have to lose 0.3. So I need to find your I1 and I2. I am giving here that this is the I1 and this is the I2. Any one current will be going through silicon, current will not be going through silicon, means we can write here I2 will be how much? I2 is 0. Okay, and I1 is current will be going through this path only here. Okay, if going through this path, then we can say your I1 will be equal to, okay, how much loss happened? 0.3. So we can say 4.7 divided by 1 kilo ohm. Answer becomes 4.7 milliampere. Clear? Okay, 0.3 will be lost. So how much will be left here? Anyone will be going through silicon? No one will be going through silicon. They will be following your germanium path, GE path. So we can say I1 will be equal to 4.7, because 0.3 is lost here. So 4.7 by 1. This one is clear. Okay, now one question I am giving for homework, because right now I cannot discuss. I will discuss in your study hour timing. Okay, study hour timing will be also same as this. Okay, same as this, we'll be having our study hours also. Clear? But now in atoms I will tell some important questions. Okay, some in 5 to 10 minutes I will tell important questions. Listen, this is the question, because in previous question it will follow least resistive path. Okay, here you have to lose 0.7 volt, here you have to lose 0.3 volt, here you will lose 0.7, which here you will lose 0.3. Where you will go? Of course, where you will have to lose less, only you will follow that path. Zener diode not there. Okay, not there. Now question is this. This is very special question, very simple one actually, but most of the people do mistake in this. So if you could get correct answer for this question, I'll be very happy. This is the exactly same question, only what is the change here in this? That this is the 100 ohm, this is your silicon, this is the germanium. Okay, here this is the I2, this is the I1. You have to get I2 and I1. Okay, I2 and I1. This total current is I. Okay, total current is I. So you have to find I1, I2. Okay, clear? This one you have to practice in a study hour. I will discuss this one. Now coming back to your atoms. In atoms, you need to first of all remember two things, that it moves on circular path. So mv square by r should be equal to k jd square by r square, means we are getting first thing mv square equal to k jd square by r. All the time you have to remember. And second thing we need to remember, mvr is always nh by 2 pi. Okay, these are the two postulate, and using these we are getting all the things. We have seen this radius formula, that was the 0.529 n square by z. Velocity formula 2.18 into 10 power 6. You know these things? We know, na? Okay. Everything is written. You have to just revise one time. Here, few questions I'm giving. You have to solve. Okay, based on the series. Okay. You know what the first line, second line, last line? Everyone knows. Remembers? What is the meaning of first line actually? That when it comes to this level, this is known as first line. When it comes from here, then this is the second line, this is the third line. And when it is coming from infinity, then this is the last line, which will be having the least energy, minimum energy. Minimum energy means maximum wavelength, that is basically for first line. And maximum or lambda will be minimum. This is for what? Your last line. Okay, last line. Clear? Question of this type are important, so I'm asking one question. Find ratio of wavelength for first line of Balmer to second line of Lyman. Second line of Lyman. Okay, this is the question. So in this one we can say first line of Balmer. Okay, for Balmer I am talking about first line. So n1 should be your 2 and n2 should be how much? 3. Okay, for the first line. And second line of Lyman, here I am talking about your Lyman. So for Lyman I can say n1 should be 1, and I am talking about your second line. So n2 should be how much? 3. Okay, n2 should be 3 here. First line and second line, and then it is over when we can write 1 by lambda equal to, it is the r, 1 by 4 minus 1 by 9 here. We can write 1 by lambda b equal to r, it will be your how much? 5 by 36. Lambda b becomes here 36 by 5 r. Okay, 36 is coming in 4 into 9, 36. In here we can say 1 by lambda L, that is the R, 1 minus 1 by 9. And here if you solve, then lambda L we can write will be the 9 by 8 R. Can you divide now? Yes, we can divide. Then we will get our answer here. So this type of questions are quite important for us. Ratio based question. First line of this, second line of this, we have to get the correct answer. Clear? This is the first thing important here. Okay, you will do practice for these questions if you find. Second important thing in Bohr is, okay, modification of energy level. Modification of energy level. Okay, you remember this one? I have given one question like this. Which energy will be modified? Means here this was your total energy was minus 13.6. Potential energy was minus 27.2, and kinetic was 13.6. Okay, EV, all are in EV. Here we can say total energy was minus 3.4. Potential was how much? Minus 6.8, and this was how much? 3.4. Okay. Potential and total is changed. Okay, only potential. Kinetic there is no change. Means if I say assume P to be 0 in ground state. Assume P to be 0 in ground state means you need to modify everything except kinetic. Okay, except kinetic you have to modify everything. Okay, so we can say in this one here, okay, you have to modify everything. Okay, so here we can say plus 27.2 because you have to make this thing 0. This is our base. Here also you will add 27.2. Okay, here means not in this. Here also you will add plus 27.2. Here also you will add plus 27.2. Everywhere you have to add except kinetic. Okay. If I say in this one, assume potential energy to be zero in the first excited state. In first excited state, then how much you will add? You will add how much? 6.8 everywhere. Okay. Assume potential energy to be zero in this first excited state here. Then you have to add how much? 6.8 everywhere. Clear? Yes. Now, can we go for next? Next thing is your relation with de Broglie. You know, electron can only revolve in which 2 pi r is equal to n lambda. So lambda will be equal to how much? 2 pi r by n, and we can write like this 2 pi by n, and this we know 0.529 into n square by z. Okay, so from here we can find the relation. It will be the 2 pi into 0.529 into n by z. If they ask de Broglie wavelength, then we can say here the wavelength for this one will be 2 pi r by n. Okay, I think if any problem is there in atoms, we'll discuss, okay, in our doubt class. Clear? If any problem is left in atoms in doubt class, okay, we'll be sitting here, okay, this chair I will be having, okay, and then you will be also live, and we will discuss if any problem is there in this, okay, in atoms. Clear? Yes? Any problem? Okay, then bye. Bye, bye, bye. Okay, bye. Semiconductor last page. Semiconductor last page was this. Okay. Other slides are not there. Okay. Yes. Bye. Details of examination will be told to you. Okay. Will be told to you.